how to build your very own polynomial and make it do what you want it to do. Say we want a polynomial that has zeros of x equals -2, 3, 2i, and -2i. But we'd also like it to go through the point 115. So I've got a very bad graph I sketched here using my mouse. So I want it to go through x equals -2. I want it to go through x equals 3, because those are my two real zeros. The other two zeros are not real values, so they won't show up as x-intercepts. And I also wanted to go through the point 115. So I know my graph should look roughly like this once I've got my polynomial figured out. To start, we know that if we have a zero of x equals c, then we must have a factor of x subtract c. This is true whether c is a real number or a non-real number. So our zeros, -2, 3, 2i, and -2i, give us factors of x plus 2, x subtract 3, x plus 2i, and x subtract 2i. So I've got 4 zeros and 4 factors. Multiplying our factors, what I did is I foiled these first two factors that had the real zeros and foiled these two factors that were complex conjugates and came up with x squared subtract x subtract 6 from these two. And foiling these two, I end up with x squared plus 4. And then multiplying these two together, I took the x squared times both of these factors and got x to the 4th plus 4x squared. I subtract x here times these two, this binomial here to get my next two, and then I subtract 6 times the binomial to get these two terms, simplifying, and I've got a polynomial. Are we done? No. So our polynomials has the zeros we want, but it doesn't go through the point 115. I went ahead and did a graph here of this polynomial, my calculator, and at x equal 1, I can see it goes to the point y equals -30. Or I can do it by hand, taking the polynomial I've developed so far, letting x equal 1, and I can see that p of 1 is equal to -30. So ours going through the point 1, -30, rather than the point 115 that we'd like it to go through. But it does have the zeros we want. We can see the +2 and the -2, 0 and the +3, 0. And again, our 2i and -2i zeros won't show up on the graph because they're not real numbers. Okay, so what to do? We want to keep the zeros we have, but we're going to have to flip our polynomial over the x-axis so that it goes through a positive value of y rather than a negative value of y at x equal 1. And we need to shrink it to half its current size so it goes through the point 115 rather than 1, -30. So if you can think hard about it and realize, hey, multiply by -0.5, great, but let's also go through a more formal approach in case that's not obvious to you. If it is obvious, great. If not, don't worry about it. We've got a nice algebraic approach to figuring out what we need to multiply our polynomial by. So we need to multiply the polynomial by a constant, and I'm going to call it a. So I've just set up my polynomial, and I've got a times my polynomial. What I'm interested in is making sure that when x is 1, the value of my polynomial is 15. So I'm replacing p of x with 15, replacing all my x values with 1, evaluating, and so I've got 15 equals my unknown constant times -30, divide both sides by -30, and my unknown constant we now know is -0.5. So multiplying my polynomial by that -0.5 will give me this polynomial. And when I do my graph, I can see that when x is 1, y is 15, so it's going through the point I desired. And I've built a polynomial. It has the zeros I want, goes through the point I want. And by the way, this is how I write test questions. I pick out the polynomials, I know what zeros I want, multiply it all together, and build a polynomial, and give it to you and tell you to find all the factors and zeros of the polynomial.